Hello, this is question 5 from the 2012 Matt. A particular robot has 3 commands. Oh, right, these are my least favourite type of Matt question. F, move forward a unit distance. L, turn left 90 degrees. R, turn right 90 degrees. A program is a sequence of commands. We consider particular programs Pn, but n is greater than or equal to 0 in this question. Basic program P0 just instructs the robot to move forwards, so P0 equals F. Program Pn plus 1 involves performing Pn, turning left, performing Pn again, then turning right. Okay, so F, L, F, R, fair enough. Write down P2. Okay, I don't mind this sort of thing. This is a easy enough starter. So P2 is going to be P1, so F, L, F, R, then an L, then P1 again, F, L, F, R, and then an R. Right. How far does the robot travel during the program Pn? In other words, how many F commands does it perform? So we get 1 in P0. In the next one up, we're going to then double that because we're going to put that in each side. So we're going to end up getting 2. Then we're going to double that up again because we're going to put 2 in there and 2 in there, and we're going to get 4. So we're going to be getting 2 to the n. Right, they're just saving the horrors for later on. I can feel it. Right, Ln is the total number of commands. So we've gone from 1 to 4. Okay, write down an equation relating Ln plus 1 to Ln. Well, that'd be easy. Hence, write down a formula for Ln in terms of n. No proof is required, and they've given us a hint. Right, okay, well, let's do the easy bit then. So Ln plus 1 to Ln, well, we're doubling it and adding 2. Because we can see this, we're getting sequence plus an L plus an R. So Ln plus 1 is 2Ln plus 2. Now we've got what I think is going to be the first annoying bit, because this is going to be pattern spotting, and they've given a hint. So we want Ln in terms of n. So I'm just going to jump straight into pattern spotting. I'm not going to try and do anything clever. N, 0, 1, 2, 3, 4. That should be enough. Ln, so we're going from 1 to 4. We're doubling and adding 2 on this. So 10, 22, and 46. And they're saying consider Ln plus 2. So Ln plus 2 will then be 3, 6, 12, 24, 48. So they've made them all multiples of 3. And we're doubling up each time. So we're going to have something to do with powers of 2. And we're probably going to have something to do with multiples of 3. So we've got 3 times 1, 3 times 2, 3 times 4, 3 times 8, 3 times 16. Right, so that certainly helps. So Ln plus 2 is 3 times 2 to the n. So Ln is 3 times 2 to the n minus 2. Right, so that was a very good hint. Certainly made it a lot easier. Robot starts at the origin, facing along the positive x-axis. What direction is the robot facing after performing the program Pn? Right, this is very similar question I had a couple of papers ago. I'm sure there was one. I think there was one where you're going around a chessboard or something like that. Anyway, you're programming it up and it was moving. It was doing exactly these instructions. This all sounds very familiar. And we had the same thing in that as well, I reckon. So what direction is the robot facing after performing the program Pn? We're adding L's and R's in pairs. They've asked this in a previous paper, I'm sure. So L's and R's get added in pairs. So you're always going to end up at the end of a program facing in the same direction, because they always cancel each other out. Right, okay. But I know there's another sheet to this because I had to copy this onto 2 sheets. So I still reckon something horrible is going to happen here. Part 5. The left-hand diagram on the opposite page, i.e. now below, shows the path of the robot when it performs program P1. Right, so that was the old FLFR one. On the right-hand diagram, draw the path it takes for P4. P4, so that's going to be long. I mean, P3 was already up to 10. P4 is going to have 22 steps in it. I reckon, let's see what the last part of the question is. I reckon trying to spot the pattern of the route might be worth it. In the last part, let that be the position of the robot after performing. So where does it end up? And then we need to get the end point. And then what? Oh, we're going up to P8 here. I reckon we need a pattern. Otherwise, these are going to be really horrible. So let's try and find a pattern of what's happening then as we're putting these together. So the first one, we're just going to be doing that. That's meant to be a forward. So that's P0. Then in the next one, we do P0. Then we turn left and we do P0 again. Okay, we have a turn right at the end, but that doesn't affect the line. So what would then happen on the next one? So the next one, you take what you've just done, which is that. Okay, it turns right at the end, but we then do a left to turn it back the way we started. And then you do it again, which will be up there and then across. So yeah, we're duplicating it, but we're doing it all in another direction. So the next one, you then do that, that, and that. That's our starting point. Then you duplicate it all, rotate it off 90 degrees. So we do that. So that's 0, 1, 2, 3. So 4 is going to be you do that, and then you rotate it all 90 degrees and do it again. So we've got that, that, and that. Then we've got that again, but 90 degrees rotated. Then we've got all of this 90 degrees rotated. So what's that going to be? It's going to be back up to there, along to there and down there, along there, down there and round there. Okay, I'm happy with that. This has surely got to help with the last part of the question. After saying I don't like these robot questions, this one's better than the previous ones they've done. I quite like this so far. Let xn, yeah, this is the position at the end. So how is the end position changing from one to another? So that would be xn, yn is what we're saying there. If that is then xn plus 1, yn plus 1. Okay, so we're getting some change in xn, yn. So we're moving up again. We're starting from that point and doing it again, but rotated. So what does that actually mean then? So let's do the difference between these two, because it's moving in both directions. It's bothering me that the first one's only moving in the x direction. So we do that first of all. So we're going x and we're going y. And we end up at xn, yn. So we end up at xy. So that's where we end up for the first one. Well, the first one in this pair for P0. I'm going to compare it to P2. So for P2, we do that first, but then we do it again up to there and along there. So that was our X and our Y, and that was our X, and that's now our Y, because we've rotated it 90 degrees. So I've split it into these two parts, X, Y, and then rotate it X, Y. So at this end point here, we're going to have our X coordinate. So that'd be xn plus 1 is going to be, we've got an x minus a y, xn minus a yn, and our y coordinate is xn plus yn. Okay, I think that seems good to me. That's where we end up. We're going to get the same thing. Yeah, we'll have the same thing on this as well, won't we? Because we've got it rotated round. Yeah, it's going to, yeah, okay. Right, so what am I trying to do? We've got that relationship between those. Okay, you could actually put them in the brackets, so write them out in bracket format. What is x8, y8? Okay, so let's go through. So we do n, 0, 1, 2, 3, 4, 5, 6, 7, 8. Then we've got x and we've got y. So for 0, we're getting 1, 0. So for the next one, so we have to take the difference between those, so we get 1, and then we add them together and we get 1. Then we take the difference, we get 0, and we add them together and we get 2. So the difference is minus 2, add them together is 2. Difference between them minus 4, add them together 0. Difference minus 4, minus 4. 0, minus 8. 8, minus 8. 16, 0. Right, okay, there we go. So that's all good. And that gives us x8, y8. Right, so 16, 0. What is x8k, y8k? Right, it suggests this is going to be repeating then. Let's keep going and see if we can get a repeat. 9, 10, 11. So difference 16, add them together, 16, difference 0, add them together, 32, difference minus 32, add them together, 32. This is following a pattern then. So we're saying up to there, and then the next one up. So we're doing them in blocks of 8. So we went 1, 1, 16, 16, 0, 2, 0, 32. Right, this is all multiplied by 16. So that is n equals 1, and then multiply it all by 16, and then so on. So every time we go round, we're multiplying this by 16 to the power of k. By the look of it, isn't it? If k is, well, k minus 1, we're going to have to do this, aren't we? But what are they asking for? So when k is 1, we're going to get that x8 is going to be 16. Y is always going to be 0. When k is 2, x16 is going to be 16 squared. And then so on. We're multiplying by 16 each time. So x8k, y8k is going to be equal to 16 to the power of k, 0. Right. Okay. That was actually a fun question. Right. I should not be so prejudiced against robot questions immediately that I see them. That one was good. That was better than the chessboard one. Well, I think the chessboard one from a couple of papers ago, whatever it was, certainly helped with the fourth part of the question. But really, it's spotting that pattern. As soon as you get into seeing how these things work out, that you do one bit and then you rotate it 90 degrees, you do it again, and you just keep on stacking those up, then that unpicks both part 5 and part 6. So again, it's pattern spotting, but I think what I liked about this one is it's pattern spotting in actual drawings rather than pattern spotting just in numbers. If it was just a case of writing out a whole load of numbers, they get really dull. But this seems to be the thing that they go for in these questions. You get these, and in question 7, the ones that they have for the computer science people, 5 and 7 in particular. 6 is always the logic question, but 7 will have those pattern recognition things again. We get a lot of those string questions that we were building up strings and spotting patterns there, which they seem to think is really important for computer science. I mean, maybe it is. I haven't done a computer science degree. Not something that I ever really think about in terms of doing computer programming, but maybe it's important for other things. As maybe when you're dealing with memory and other kind of processes that go on inside of computers, less so maybe on the programming side. I don't know. Maybe I just don't come across it in my day job. Maybe that's what it is. But that was quite a nice question actually. This has been a good paper so far. I've enjoyed the ones they've had thus far.